let's suppose we have f of x equals x squared. So this is an example, because I want you to remember this. So let's say f of x is x squared, and let's say the point is 2 comma 4. When x is 2, 2 squared is 4. And we want to find the slope of the tangent at P. That's all we want. We don't want to find the equation. I just want to find the slope of the tangent at P. What do I need to do?
Find f prime.
Very good. So can anyone give us f prime?
2x.
Very good. And then, how do I find the tangent at P? I have f prime. How do I find it?
Plug in 2.
Exactly. Plug in 2. So this is f prime of 2. 2 times 2 will be 4. So please remember, this is one of the most important concepts in this class. Therefore, because this is x, the slope of the tangent line at the point P with x being x must be f prime of x. Okay. So, is there another way of determining the slope of a line? What is the definition? Forget about calculus now. What is a definition? When we first studied the slope in algebra, what did we say?
y2 minus y1 over
Yes.
x2 minus x1.
Excellent. Rise over run. Excellent. Yes. Since I'm not going to write y2 minus y1, but that's exactly what you just said, because I don't have those 2 points. Although I could consider, but we don't have those points. So rise over run. Rise over run. But these have to be the same. The rise over run and the slope of this line, they have to be the same. It's only one line. We established that this is f prime. We know that rise over run gives us the same thing. I would like somebody to guess. What do you think that is? We've seen it even today. We've seen it for a few weeks. There is only one option for what is missing. What would that option be?
dy.
Absolutely. Exactly dy, which we said is the different, thank you so much, differential, not the derivative, of f of x. The differential of f of x. Indeed. Awesome. So I'm coming back, and now we know that this is dy. This is dy. dy, we know what it means. Where's my page? dy is the approximate error, the differential of y. Okay? So this is dy, and this is delta y. This is the exact, and this is the approximate. But remember, what you see here is maybe confusing, maybe deceiving. Q is very, very close. You can say, wait a minute, the approximate is so much bigger than the exact error. No. Q is right here. So then, this is our discovery. What should I put here? That expresses a relationship between the exact error and the approximate error. And these are our possibilities. Let's eliminate. What would you eliminate? Let's take it by elimination. What would you eliminate from these 6?
Equal to or approximately equal to.
So which one would you eliminate? First of all, one by one.
I would eliminate equal to.
Done?
Approximately equal to.
Why?
As well.
Why?
Because they're because f of x, I mean d of y is greater than this y.
It doesn't matter.
No.
We don't know if that's the case. We don't know if that's the case. What if q is on this side? This is just an example.
Okay.
So we do not know this. We do not know this. We have no idea about this. We have no idea about this. They are approximately the same. They must be. Of course, if you say that the error is 10 inches, they will never be the same. They will never be approximate. The error has to be tiny. In other words, they have to be close to each other. Q is here. So if for a small x, for a small dx, these two will be very close to each other. So let's look at an example. See how we illustrate this. And I already have the book open unless I am logged out. So let me see where my book is. Here it is. Where are you guys? Here you are. I'm sharing my screen. Okay, so page 341 actually. 341. Look at that, I'm not logged out. Find delta y for the given x and delta x values. Then find dy. I'm going to talk about this in a minute one more time. And find dy for the given x and delta dx. So let's choose anything from 1 to 12.
We do 10.
10. Very good. So for 10 we have f of x equals e to negative x equals 1, delta x equals negative 0.2. Did I copy all of them from one problem? Because sometimes I copy from different problems. Okay, good. So before we attack this, this problem, we have to remember this definition or this relationship, that the exact error is very close to the approximate error. I'm going to replace this but what it equals to, which we already know, f of x plus delta x minus f of x. The squiggle is simple, and now we have to decide upon this. Just remember, we wrote f prime of x equals dy over dx. This is over 1. Can anyone cross multiply and tell us what dy equals to? We cross multiply and we want to find dy. Can anyone say it again?
1.
Dy times 1 equals
dy.
dy times 1 equals we cross multiply. Dy times 1 equals,
Would it be f prime of x times dx?
that's it. So this is the formula for the differential of y. Dy times 1 equals f prime times dx. I'm going to copy it here. So f prime of x dx. So because I have dx here, I'm going to be consistent and replace this by dx. So please remember this. This is very important. We're going to use it in the next few minutes. Okay, for now, for this problem, we're asked to find delta y and we're asked to find dy. We're not asked to approximate anything, so this is very, very important formula. We're going to get to it in a minute. Right now, for this problem, for problem number 10, we're given a function, we're given x, we're given delta x, which is the same, of course, with the x, same value. And they're asking us to find delta y and dy. And show, because delta x or dx, it's a small number, right? It's a small error. Show that these two are quite close. Okay, first I have to write a definition for delta y, which is f of x plus delta x minus f of x. And then I have to write a definition, which we just discovered, f prime of x dx. These are the two questions that we have to answer, this and this. Okay, given the information in the problem. Okay, perfect. So this is my page 6. So then, x is 1, and y, I'm sorry, x is 1 and delta x is negative 0.2. So, delta y equals x plus delta x. X plus delta x is 0.8. I don't want to confuse you. I have to remove this from there. Okay. So, again, x plus delta x plus delta x is 0.8. So, f of 0.8 minus f of x, which is f of 1. The function is e to negative x. So this is e to negative 0.8 minus e to the first power. So I'm going to get this with a trusted source. I have the calculator too. So I have e and the power. No, I don't need that. It already pops up. Negative 0.8. Please always check my numbers, always, minus e. Okay, e to, okay, I got negative 2 point, let's say 4 digits, 4 decimal digits. I got negative 2.28, I'm sorry, 26895. I copied 5 decimal digits. Okay, good. So this is the exact. Now we want to determine the approximate. So that will be dy equals f prime of x dx. And f of x is e to negative x. I have to find the derivative, and I have to multiply it by negative 0.2 after I plug in 1. So can anyone give us f prime for e to negative x? What is f prime for e to negative x? Anyone, please. The derivative of e to negative x.
Would it be negative x to the e? That's not right.
So remember, it's e to a function prime is e to the function times the inner function prime.
What would it be?
Negative e to the negative x.
That's it. And now, of course, I have to plug in 1. So f prime of 1 will be negative e to negative 1. So now I can calculate dy as negative e to negative 1 multiplied, don't forget, to operational symbols. I have to put parentheses. And now, please calculate this with me. I don't need to put the two negatives, obviously. It is 0.2 multiplied by e to negative 1. So, two negatives make a positive when I multiply them. So I have 0.2 times e to negative 1. And my calculations give us something that is not right. One or the other are not right. 0.073576. So it doesn't make any sense because they have to be close. The error, although because of E, they that is possible. That is possible. So E is a little bit of a problem because e to the x, as you know, this was e to negative x, so it's 1 over e to the x. So it could be, but I want to check my calculations. Where is my first page here? Okay, so we had e to negative x. Did I put, I got it, sure. I said 0.8, but I put negative 0.8. So it was 0.8, but I put negative 0.8. So this is incorrect. They can't be that far. So it was f of 0.8, however, I put negative 0.8. Why? No reason, no excuse. Okay, so e to 0.8 minus e to negative 1. So where did I copy? I don't know where I copied. It was e to negative x. So e to, so we had, oh, it was e to negative x. Oh, I got it, sorry. So 1 minus 0.8, that was correct. So it was 0.8, so this is true. It's negative 0.8, so I'm going to change that. And here, e to negative 1, that was my mistake. E to negative 1, that's it. They have to be close. So this was okay. The other one was not. Okay, so now, that was to power negative 1, and this was indeed to power negative. Okay. Now it makes sense. So this is 0.081445. This is the exact, and this is the error. And this is the approximate. Okay, so then one more time. The function was e to negative x. F of x plus delta x is 1 minus 0.2, which is 0.8, but it's negative. So it has to be e to negative 0.8. Minus f of x with x being 1, e to negative 1. So now this is correct. E to negative 0.8 minus e to negative 1. I'm doing this again. E to negative 0.8 minus e to negative 0.1, and this is the exact. 0.081445. Now, when we calculate the approximate, f prime of x dx, f prime of x, that's correct, negative e to negative x. We only have to plug in the easy part, which is 1, so it's negative e to negative 1. And delta x or dx is given to us as negative 0.2. Now I'm checking everything. Once I made an error, I check again. So negative times negative is positive, and I'm checking again 0.2 basically divided by e. And that's correct, 0.07357776. So indeed, we can say that 0.0814495 is approximately 0.073576. This is the exact, and this is the differential or the approximation. This was so much easier to calculate than over there. You can say for this function, both are kind of difficult to calculate, yes, but this is a quick solution or quick answer They're not equal. They can never be equal. That's not possible. This is the exact and this is the approximation. Any questions on this problem?